Assalamualaikum and warm greetings from Terengganu. First of all, congratulations for having made it this far in this course. You have surely noticed as you progress in this course from one topic to another, you have in a way been gradually expanding your knowledge on different perspectives of fish parasitology, from parasitic protozoan to metazoan, as well as some of life cycle of the parasites. In this topic, we will see yet another aspect of fish parasitology, where we will learn briefly about the use of fish parasites as biological indicator for host species ecology and environmental changes. This course begins with an introduction to the diverse parasites and their usefulness as bioindicator tool and a definition of biological indicator. The following section will touch briefly on parasites as indicator to ecosystem changes and health. This section will provide a preview on the role of parasites as indicator of pollutants as well as their role as indicator in trophic interaction. We will then learn about parasites as indicator of host biology, where it will help you to understand some aspect of host biology that can be predicted by parasite. Then, in the final part, we will explore some selection and criteria of parasites before you can choose them as one biological indicator species. So let's start the course. On the basis of a conservative estimate, an average of 3 to 4 parasites can be found in each existing fish species. With a current number of 31,400 described fish species, we can estimate the existence of up to 120,000 fish parasite species that include both protozoans and metazoans. Combined with a number of life cycle stages that may infect all aquatic hosts and organs, this vast biodiversity represents a widely neglected yet effective tool for a variety of ecology-based applications. In fact, various studies have demonstrated that fish parasites can serve as biological indicator organisms to illustrate the ecology of their infected hosts, including feeding, migration, and population structure. So, what is biological indicator, or elegantly called bioindicator? Well, as a rule, bioindicator include biological processes, species, or communities and are used to assess the quality of the environment and how it changes over time. And not all biological processes, species, or communities can serve as a successful bioindicators. However, parasites has been used as biological or natural tags, indicators, or markers for almost a century. With the earliest records of uses as indicator of different intraspecific populations of aquatic hosts are back in 1939. As science progressed, numbers of research has utilized and approved the successful use of parasites as biological indicators for both environmental changes and host biology throughout this century. At the higher environmental level, parasites are increasingly being used as bioindicators of environmental quality due to the variety of ways in which they may respond to anthropogenic changes on the environment. Parasite metrics has been connected to specific environmental conditions, and they can indicate different pollutants such as heavy metal, concentration, industrial and sewage pollution, and also eutrophication. Information obtained from such studies could somehow indicate changes or transformation which happens in the environment. In this slide, I would like to share with you an example of a study that used parasites as pollutant indicator. In this study, the winter flounder Pleuronectes americanus and its parasite were examined for stress-related exposure to untreated pulp and paper mill effluent in a 5-year field study. One of the significant findings was the fish taken near the paper mill outlet exhibit external and microscopic lesions with higher number of prevalence of ectoparasite Cryptococcylia lingua. This study is just one of the many studies that provides an evidence of the use of parasites as a valid and an additional bioindicator in monitoring environmental contaminants. On the role of parasites as indicator of trophic interaction, assemblage of diverse parasites within a host organism potentially reflects what or where is the host position within the food web. This is because the life cycle of some parasite is rather unique and targeting few hosts before it could be completed. For example, occurrence of parasite within a single fish species may indicate what are the other animals that may be around the ecosystem, like birds, otter, or even humans, since the fish is just the intermediate host for that parasite. Hence, parasite populations and communities may portray as useful indicators of food web structure and biodiversity. Now that you have understood the use of parasites as indicator for environmental changes and their role in trophic interactions, let's see what the parasite can indicate at their host level. You might have noticed by now that most parasites are specific to a host species or to a group of closely related hosts, which means parasite A only attached to fish A and parasite B only attached to fish B. With that simple equation in your mind, the abundance and occurrence of parasite has helped parasitologists directly relate to the diet and feeding behavior of the host, distribution, migration pattern, population biology of their host, fish stock separations and identification, fish recruitment migration, and risk assessment of fish food-borne zoonosis. So, by using parasite as biological indicator, various data, as you can see here, could be provided in one single study. The use of parasite as biological tag was not only limited and restricted to fish study. For instance, they have been used as a biological tags of cephalopod hosts in many regions in the world, as summarized in Pascal and Hochberg in 1996. Unlike conventional mechanical tagging methods, parasites do not interfere with normal cephalopod behavior and does not involve catch and release methods, which are known to cause mortality to tag hosts. On the other hand, parasites has also been used as indicator to study marine mammals ecology, where Balbuena et al. Has conducted a study using parasite to indicate the social structure and stock identity of forest pilot whale. As we have seen the various utilizations of parasite as bioindicator, especially in fish population studies, I would like to now brief to you on what does it take to be a successful bioindicator species. Well, there are various agreements on the ideal criteria for successful parasites before it can be used as indicator. And for this course, I have summarized them to 9 major criteria, which will be explained through. The first one is that the parasite must differently abundant in various localities, where it must show significant different level of infection in the subject host in different parts of the study area. In the example I have given here, the parasite showed different prevalent level at different localities of investigation, giving the clue of stock separations of the fish host. Secondly, we must consider that a tag parasite should include in its life cycle only the subject host or single host life cycle. This is because parasites with complex life cycle involve more work and a wider investigation. Thirdly, the parasite should have a lifespan or remain in an identifiable form in the subject host long enough to cover the time scale of the investigation. Fourthly, the infection data can be analyzed according to prevalence, intensity and abundance of infection. For seasonal study, it was suggested that prevalence of parasites should remain stable from season to season and from year to year. From these seasonal variations, data can be used to determine seasonal migrations of the subject host. The fifth criteria, on the other hand, is rather related to environment of that targeted study areas. It was suggested that environmental conditions throughout the study area should be preferably within the physiological range of the parasite intended as a tag. This is to avoid bias in sampling processes. Hence, a good knowledge of range of tolerance of different stages of a proposed tag parasites and its host to various environmental factors is important. Other than that, unfavorable conditions can act directly on free-living larvae stages of endoparasitic helminths and dispersal stages of protozoan. Lastly, environmental conditions may also act indirectly by limiting the distribution of other hosts which are essential to the completion of the parasite life cycle. Finally, for the last four criteria, it's rather straightforward and graphical, so I would like to describe it with the help of this figure in the middle. This image is a nematode worm Paraphylometroides nematri attached and found from Nemapterus peroni in Malaysia. So, the sixth criteria of a good parasite as bioindicator is the parasite should be easily detected, easy to collect, with large body size and availability. Next, the parasite should be easily identified at least to the genus level. If a parasite is easily confused with another species, it means the time taken to confirm the identity of each specimen may become a limiting factor on the host. Then, the parasite should have no marked pathological effects on the host or not serious pathogens that could affect host behavior. And lastly, method of examinations of targeted parasites should involve the minimum dissection like you can see in this figure. All you have to do is to flip the dorsal fin and there you can find the lovely nematodes. So, a very high degree of site specificity of the parasite is a huge advantage for you. We have now reached the final part of this topic. Having understood aspects of parasites as bioindicator, now I would like to skim through with you some examples of previous works that use parasite as bioindicator based on their domains. And again, I would like to remind you that what I have listed here is mere numbers of various studies that have been conducted out there. For example, nematode has been used to study Pacific herring population in the Northern California in USA and white hake population in the Gulf of St. Lawrence in Canada. Next, several cestodes has been utilized in indicating the Australian salmon biology in South Australia and hake in southern Chile. On the next example, several Digenea and Monogenean species has been used to study various host species, mainly cod and trout from Canada to North California down to southern Chile. And lastly, for acanthocephalan, utilizations as bioindicator range from mammalian hosts, the Faroes whale, to regular bony fishes such as white hake and rockfish. And as for mixozoan, there has been an indicator for Mesu salmon biology in Japan as well as cod fish of Norway. As a conclusion, fish parasites can elucidate problems in a variety of applications. They can be used as biological indicators for their hosts, accumulation indicators to detect pollutants, and eventually provide information on the health status of the environment. We have also learned, however, a proper selection of the parasite utilized and their specific life cycle stages is a prerequisite for all these applications and requires careful planning and some background information on the parasite diversity within each habitat. Nevertheless, the parasite as biological tags method that has been described will continue to be important in determining various aspects of the host's natural history. And in the future, integrated studies will increasingly use the parasite meristic, morphometric and biochemical information to complement artificial tagging. I hope that you enjoyed the lessons given in this topic on the utilizations of parasites as biological indicator. That's all from me, and hopefully this course will be useful for all of us. Thank you very much again for your attention, and goodbye.